Hello. In this tutorial series, I will show you how to create and style a graph in Matpotlib. And we're going to be making this, a graphical display about the declining views and ratings of The Simpsons. This will involve two graphs stacked on top of each other. The top one is the line chart with the views in millions, and the bottom one is the bar chart with the IMDb ratings for the show. We also have some titles and short pieces of text that display what is considered the two eras of The Simpsons. So we have the golden era of the show and then the zombie Simpsons period later on. And the axes are customized and the entire thing is styled in the iconic Simpsons color scheme. And just to keep the videos short and to the point, I will separate this tutorial into two parts. Part 1, so this video, I will create the basic graphs and the text. And in part 2, I will apply all the styling. So in this part, I will show you how to create and customize the graphs. And here are the topics I will cover in particular if you look for something specific. And it doesn't actually need any complex code whatsoever. So if you have even a tiny amount of knowledge of Python, you should be good to go for this one. And yeah, that's it. So let's start. But before we can start, we have to install some things. For the graphs, I will use a module called Matpotlib, which is the most widely used library for this kind of purpose, and it has some really good documentations online. But it doesn't come with Python by default. So on your computer, either open the terminal or the PowerShell and type pip install matplotlib, and things should get installed. And once you are done with that, go to your code editor and type import matplotlib. If you can run that code without getting an error message, you are ready to go. So to Matpotlib then. Matpotlib is actually quite simple, at least in theory. You have lots of functions and you just need to pass in some data and then you get a graph. And that's really it. Most of the time, organizing your data is actually much more difficult than visualizing it. But that won't be an issue for this tutorial, since the data is quite simple. Broadly speaking, there are two ways to create the graphs in Matpotlib: the functional approach and the object-oriented approach. The former one is a little bit faster and easier, but less flexible, and the latter one being more powerful, but needing a little bit more work. Since I will style the graph quite a bit, I will go for the object-oriented approach. And to understand this style, you need to know a few basics about a graph from Matpotlib. At the most basic level, there's a figure. This is basically just an empty canvas. It cannot do much itself, but it can hold all the other elements that do more useful things. The element that actually contains the graph is called the axis, which is just an empty set of axes that starts at 0 and ends at 1. It looks like this, and you can have as many axes on a figure as you like. And to those axes you add the actual graphs and you get the visualized data. If you don't specify any styles, you get Matplotlib's default styles. But that being said, you can customize and style every single element. I will actually build up the graph in this way. So let's start by creating the basic figure and axis and put some graphs on them. Within the object-oriented approach, there are two ways to create the figure and the axis. You can use plt.subplots and insert the number of axes you want as an argument, and Matplotlib sorts them in a grid for you. The other way is to manually create both the figure and each axis that you want, but you would need to set the size and the location yourself. While the latter option takes a bit more work, it gives you much more freedom to place the elements, so I will use that one. And with that one, we can finally start some coding. So on the first line in the code, I import Matplotlib. The convention here is not to import Matplotlib as a whole, but rather to import matplotlib.pyplot and abbreviate it as PLT. And on the next 4 lines, I will paste the data that will be visualized. I prepared this one already. So I have the names of the seasons, the year that season was run, the IMDb ratings for that season, and the views in millions. And each of them is a separate list. The one thing you need to be aware of is the order of these lists. I emphasize that with some white space. The first item in every list refers to the first season, and the second item in every list refers to the second season, and so on. This order is important because it is the only way we can connect the data points. Each list is an individual element, and there's no way for Matplotlib to know that the points belong together. and only by having the same order for every list can we make sure that the points stay connected. Basically, think of each list as a row and each list index as a column. So we basically have an improvised table. I am only using this here for simplicity because we have a simple data set. If you want to learn how to properly store data, check out tutorials on NumPy arrays and Panda data frames. But with the data established, we can start creating the graphs. I first need to create the figure. This is done with the command plt.figure, and I will store it in the variable fig. This will create a blank window. We can actually see this. The only thing needed to do is to add plt.show and execute the code. And we have an empty window with some options in the bottom, and we can also resize it. But not much else, so I'll close it. I will add one argument into the figure, and that is the size. The parameter for that is called fig size, and it needs a tuple with the horizontal and vertical space. And for some reason, this is measured in inches. I will pass in a tuple with 12 and 8, and that is going to be my final size for the figure, and I will avoid resizing it. The reason for that is that placing something on a static graph is much easier than placing it in a way that remains consistent when the scaling changes. Just to illustrate this, here's the final graph that looks fair enough, but if I scale it basically in any way, it falls apart quite noticeably. But that only happens because Matpotlib scales every element individually. If I save this graph as a picture and scale it, then everything works just fine. But anyway, back to the code. The axis is added by calling addAxis on the figure, and this returns an axis that we can store in a variable. So right after creating the figure, I add x_ratings and assign it fig.addAxis. And if I execute the code now, we still get an empty window. That happened because we didn't give the axis any dimension. Let me explain how that works. Into addAxis, we need to pass in a list with 4 elements. The first 2 determine the x and y location of the axis, and the other 2 elements in the list control the x and the y size of the axes. And all of these values are between 0 and 1, and they are relative to the figure they are placed on. And also note that the starting position is always the bottom left. So if I add 0.1 and 0.2, the bottom left of the axis would start 10% from the left and 20% from the bottom of the figure. And if I then add 0.4 and 0.6, the axis would occupy 40% of the width and 60% of the height of the figure. So it's actually fairly straightforward. Let's implement this in the code now. I will start with the ratings, since those go at the bottom. I add x_ratings with add_axis and insert the list with 0.05, 0.05, 0.9, and 0.35. So this axis starts at 5% from the left and the bottom. It occupies 90% of the horizontal space and 35% of the vertical space. And the second axis should be right above it. So for x_views, I call add_axis with 0.05, 0.45, 0.9, and 0.5. So the axis will start at 5% from the left, 45% from the bottom. So it will also take 90% of the horizontal space, but 50% of the vertical one. And running the code now gets us the figure with the axis. And with that one done, we can talk about adding the bar chart and the line plot to these axes. These two are respectively added with .bar and .plot. Both of these methods have a fairly similar syntax. You first have to pass in the data as arguments, and then you can add optional style arguments. And that pattern basically applies to all graphs in Matplotlib. For the bar chart, there are a couple of parameters that you need to pass into. Here's the entire documentation for it. I will use data for the x-axis, which needs categorical data, and the height parameter. The other parameters can be used for more advanced bar graphs, but I won't be needing them here. For the line plot, the documentation looks like this, and I will need the x, y, and the data parameter. But I won't be using any formal strings. And that's all we needed to understand to make some graphs. So let's implement all of this now. In the code, I add x_rating with .bar, and I pass in x equals season and height equals ratings. And this would already give me the bar chart. And you don't actually need to insert the parameters specifically. To demonstrate that, for the line plot, I will just call .plot on x_views and insert years and views. And if I execute the code, we get the graph that conveys some information, but it looks pretty dreadful. There's no title or indication what the graphs represent. The labels for the bar charts are a nightmare, and the bars itself waste a huge amount of space. And the colors are also quite bland. But it is a start, so let's start by cleaning all of this up. The first thing I will do is to make sure the code is well organized. I will organize my code into 4 groups and give them headlines with comments. I add one for the data, then I have a general setup, and then 2 more for the ratings graphs and the views graph. Later on, I'm going to make another chunk of code for the styling. And all of this is just to make it easier to keep things organized and avoid really confusing code. And with that one done, let's look at the bar graph, because that's by far the worst part right now. I want to change it so that it only shows season 1, 10, 20, and 30. And on the y-axis, I only want to display the ratings between 6 and 9, since The Simpsons never went above or below that range. Just to be clear on the naming conventions here, the labels on the axis are called ticks in Matpotlib. So the horizontal ones would be x ticks and the vertical ones would be y ticks. And you have a number of ways to influence them. One that I will need is set_x ticks. And this one determines which ticks are shown on the x-axis. To understand how that works, think of every tick as an item in a list. For the ticks on the x-axis of the bar chart, I have a list with 30 elements. The first one being season 1 and the last one being season 30. And like any list in Python, the index starts at 0. So season 1 would be index 0, season 10 would be index 9, and so on. Now, set_x ticks wants to know which elements to pick from this list. So if I pass in a list with 0, 9, 19, and 29, it would only show these elements. It basically works like indexing, so it should be quite easy to implement. Below the line where I created the bar chart, I had x_ratings and add set_ticks and insert a list with 0, 9, 19, and 29. And if I run the code now, we can only see certain seasons, and that already improves the look dramatically. And while we're at it, the line plot doesn't actually need any ticks on the x-axis. And to get no ticks, all I need is to call set_x ticks on that axis and insert an empty list. And running the code now, things are looking quite a bit cleaner already. Now let's fix the bars. If you look at the bars, they're all far too long. Since no season of The Simpsons had a rating lower than 6, we can safely start the graph at 6 instead of 0. And we can also make it end at 9, since the highest rated Simpsons season had a rating of 8.4. And to achieve all of that, I need to create a limit on the y-axis, which is done with set_ylim. And it just takes 2 arguments, the bottom and the top of the limit. You can also do the same for the x-axis with set_xlim, but I don't need that here. So back in the code, I call x_rating and I add set_ylim, and I insert 6 and 9. And executing the code now, we can see that the bar graphs are much clearer in terms of how the ratings have changed. This actually happens automatically for line charts. If you look at it, this one automatically only shows the range that actually has data. So yeah, we're making progress. But it is still unclear what the data actually represents. So I want to add a title for each graph. The first one should say views in millions, and the second one should have IMDb ratings. This is actually really easy. You just need to add set_title on each axis and insert whatever string you need. So back in the code, I add .set_title for each axis and insert IMDb ratings for the first one and views in millions for the second one. Both as strings, obviously. If you run the code now, we can see the titles. And one last thing I would like to add, and that is some text. For the line chart, I want to add 2 pieces of text for 1998 and 2018 to indicate the years. the first and the last point in the dataset respectively. And in the bar chart, I want to add two pieces of text as well. And they should say Golden Age and Zombie Simpsons. And for those two, I want to draw a box around the text to make it easier to read. And for each of these, we just need one function, and that is called text. Text is called just like the bar plot or the line chart. You identify the axis you need, and then you add the command, text in this case. Then you specify the data, which in this case would be the location and the text you want to display. And then you have lots of ways to customize this information. For now, let's just add the text for the line chart. I already know what information I want to pass in, the respective years, but I do need the coordinates. And technically, I already have those as well. You see, text uses the existing grid for the location. So for the line chart, the x-axis ticks go from 1989 to 2018, and the y-axis ticks from 3.1 to 27.3. Since I want to place some text right next to the beginning and the end of the line, I will call the text twice and use the first and the last coordinates from the data we already have. Let's do all of this in the code now. Once more, I add x_views followed by text, and I insert 1989 and 27.8 and the string 1989. Just to illustrate this, let's run the code now. And we can see the string 1989 right next to the starting point of the graph. It is a little close, so I will add a bit more distance between the two. So I close the graph and change 1989 to 1989.2. And that should add some horizontal space. With that one done, I just need to add the second piece of text at the end of the line. This one will be 2018.2 and 3.7 and the string 2018. And executing all of that, we have the text for the line chart. Now to the bar chart. The text for that one is added in just the same way, with one small difference. Since the bar chart doesn't have an easy number to use on the x-axis, we just need to insert the index for it, with 0 being the first element. So I will add 2 and 7.5 and the words Golden Age on the first text. And the second one gets 19, 7 and the words Zombie Simpsons. And all of that gets us some text. But I also want some boxes around the text. And for that, I need bbox. bbox is just another parameter of the text function. And it allows you to draw a shape around the text and customize the look of it. And this one always needs a dictionary. For now, since we worry about the style later, I will create the box with the default styles. So all I need for now is just the argument bbox and assign it an empty dictionary. And I will do that for both pieces of text in the bar chart. And running the code now, we can see that there are boxes around the text in the bar chart. And generally, it all looks much cleaner and more understandable. And with all of that one done, we have actually created the basic graph. And in the next video, I will show you how to turn it into something that looks much more like The Simpsons. And we will touch almost all the elements of the graph and change their styling quite a bit. So I'll see you then.